Today we're going to talk about graphing in standard form. It's very similar to graphing in vertex form. Very similar to graphing in vertex form. The only difference will be finding the vertex. It's a little bit more difficult to find the vertex when we're in standard form. But once we found the vertex, all the rest will be the same. We'll identify the same things. We'll do slope the same way. So it's not going to be a whole lot different. So our goal today is find the vertex in standard form. In vertex form, it was pretty easy. Well, I said, yeah, no, that was the right word. Vertex in standard form. And graph. So since we have to find the vertex a little bit differently, we won't actually have to identify the horizontal and vertical shift. We have to do something else instead of identifying horizontal and vertical shift. But then our slope will be the same, and the rest of our information will be the same as when we were graphing in vertex form. So let's review the two forms again. We had standard, we had vertex. Standard form was the y equals ax squared plus bx plus c. Vertex was y equals a times x minus h squared plus k. So in vertex form, it was easy to find the vertex. We usually called it horizontal and vertical shift because it slides our graph around. So our vertex in vertex form the actual vertex were these numbers here and here, but we did change the sign of the one inside the parentheses. Instead of negative h, positive h. In standard form, we are going to need a formula in order to find the vertex. So in standard form, our formula for the x-coordinate of the vertex is x equals negative b over 2a. So that's a formula we'll have to have memorized. Now this is one formula I actually know where it comes from, but we need more information before I can show you where it comes from. We need to know how to do something called completing the square before I could show you where we get that formula. Well, if we have an x-coordinate, to find a y-coordinate, we just plug the x-coordinate in. So for the y-coordinate, we plug x into the function. I would replace the letter x with whatever number I got. Everywhere I saw the letter x. So most of the time we'll have to do it 2 times. In the x squared spot and in the x spot. So using this formula, formula will replace finding horizontal and vertical shift for standard form. But again, all the rest is going to be the same. We still find flips by if there's a negative in front of the entire equation. We still change slope by the number in front of x squared, the number in the front, a. Our stretch and shrink is still determined by a. Vertex, we find our new way, but we still find max axis of symmetry, domain, and range the same way. So it's very similar to what we've already been doing. So let's do an example now. Like I said, it's not that much different. The only different part will be finding the vertex itself. F of x, that's another way to say y, equals negative 2x squared plus 4x plus 8. So we are going to, instead of start by identifying the horizontal and vertical shift, we need to start by using this formula. So we start with the x coordinate of our vertex. X equals, well actually first we should start by identifying A, B, and C. I can't use a formula if I don't know what A is, B is, and C is. So A is always the number in front of x squared. I could totally rearrange the order of this, and A is always the number in front of x squared. So what is A? 2. Negative 2. What is B? 4. And now, C is not part of the current formula we need, but we need to practice identifying it now. In a week or two, maybe a little bit longer, we will need C. So we start now identifying C, even though we don't have to use it in our formula. So now I start with my formula. It's negative B over 2A. I'm going to replace B and replace A. Every time I replace stuff, I usually put it in parentheses because it helps avoid mistakes. So we have negative from the formula, and then here I replace it with what I had for B. So what did we say B was? 4. Over 2 from the formula, negative 2 because that's what we identified A to be. So now I simplify this. I want one number if at all possible. If I can avoid fractions, I want to. I believe on the assignment you're not going to have any fractions. I think I set it up that way. So we have negative parenthesis 4. If we have a negative outside of positive, what do we really have there? If we have a negative times a positive, negative still. Really, it's more important if we had a negative outside a negative, can you change positive, which is why I put it in parentheses. 2 times negative 2 is also negative 4. And then we divide. What's negative 4 divided by negative 4? 1. Now the reason I'm writing the work over here is because I'm going to graph over here. So that would be the x-coordinate of our vertex. I'm going to give some space because we still have to find the y-coordinate. But the x-coordinate is 1. This again is replacing our horizontal shift. We know the x-coordinate, that's basically our horizontal shift. So now we have to find the y-coordinate. I can't plot a point unless I have 2 values. So we take the value we just got 1, and we plug it back into the function. So our y coordinate equals -2. Instead of x, I put a 1, but I do still put squared. So again, everywhere we see an x, that is what we are replacing. And I always, again, put it in parentheses to prevent some problems that can happen if you do not. So now we simplify this. If you have a graphing calculator at home, you could plug it in like that. As long as you include the parentheses, you could plug it straight in and get your answer. Or if you have some of the scientific calculators, you also can do, like it'll show the problem as you write it out. But if it doesn't show it as you write it out, we've got to do order of operations. So order of operations says we do exponents first. 1 squared is 1. So next order of operations, we would multiply. So first we did 1 squared. 1 times 1 is still 1. If it's anything other than 1, it'll change, but since it was just 1, it stayed the same. Then we multiply. -2 times 1 is -2. 4 times 1 is +4. And we leave the +8 for now. And then we add it all together. -2 plus 4 is 2. Plus 8 is 10. So there's our vertex. Again, knowing the vertex, that replaces our horizontal and vertical shift. This is our first point. We'll plot this first. So before we could graph, besides knowing horizontal and vertical shift, we needed to know slope, and if it flipped, and if it was a stretch or a shrink. So again, we find these the same way. Slope normally is 1/1, 4/2. What am I going to multiply that by according to this equation? What's the very first number? -2. That's what I changed my slope with. Just like in vertex form, the very first number changed my slope. If it's a negative, we still flip. So flip is yes. Slope, we multiply 1/1 by -2, so -2/1. We multiply 4/2 by -2, so -8/2. And then is it a stretch or a shrink? Is that number out front, the -2, we consider that an integer or a fraction? Integer, so it's a stretch. So now we can graph our function, and again, we'll still need to name the stuff after, but we already have the vertex, so we just need to name it if it's a max or a min, axis of symmetry, domain, and range. So since our vertex is 1, 10, we're going to need a lot on the upper part of our graph. So when we draw it, we're not going to center it. We're going to offset it like this. Because we need at least 10 tick marks. 7, 8, 9, 10. On the assignment itself, the graph will already be offset for you if it needs to be offset. So you won't have to worry about that on the assignment. Yes. So now we plot our vertex first. We actually plot that coordinate, 1, 10. From the center we go right 1, up 10. That's our first point. Just like our horizontal and vertical shift in vertex form got our first point. From that first point, we always do the slope. Slope in this case is negative 2 over 1 first. So down 2 over 1, down 2, left 1. Sorry, that dot in the middle is an accident. Then we do our second slope, down 8 over 2, down 8 over 1, 2, down 8 left. Oh, sorry, I'm off. Over 2 would be here. Down 8, left 2. And then we could connect them up. We know it's a U shape. So don't make them connected by straight lines, curve it. So we connect our U shape and then we name all the things we named when we were graphing in vertex form. We already have the vertex. We had to find that in order to graph this time. Do we have a max or a min? Maximum. Axis of symmetry is still x equals the x coordinate of your vertex. What was our x coordinate? 1. Oh, we should be graphing that in too. I always forget that. I don't know why. I do want you to draw the axis of symmetry in. So I forgot to do that on the homework, but we do need to get in the practice. Domain, same as vertex form. All real numbers, all the time for parabolas. Because if we keep drawing these arrows forever, they go to the right forever, they go to the left forever. So domain is all real numbers. And then range still starts with y. Then we have to decide which one, less than or equal to or greater than or equal to. Is our graph facing down or up? Down, so should we use less than or greater than? Less than. And then it's always less than or equal to the y coordinate of the vertex, so 10. So it's really, again, not that much different from graphing in vertex form. So I want to do one more example. We're not even going to do the whole thing. I just want to show you one thing that could happen when you're solving for the vertex. So we're not going to graph this one because the graphing isn't different than from vertex form. We've had a lot of practice with that. So you're probably getting bored doing it over and over again. But I do want to show you something that can happen. I'm going to be over 2a. When you plug stuff back in when you're solving for the vertex. So again, this one we're not going to graph this one, we're just going to find the vertex, because that's really the only new thing we're doing today. Is finding the vertex. On the wall. Yeah, you can. So again, we start with our formula, so we have to identify what's A, what's B, what's C. We need those pieces of information before we can graph. So in this case, what is A? What's the number in front of x squared? 1. We have our invisible 1. Just like we practiced with factoring and with square rooting, we get a lot of these invisible 1s. What's B? 6 is the number in front of x, not the exponent. So that's a good thing to point out. And then C is -4. Again, we don't need C for our current problems, but it's good to start identifying it now because we will need it later. So, Mayella, what formula do I use to find my x-coordinate?
B and A.
Okay, we use B and A, but what's the actual formula? X equals negative B over 2A. So we have negative, B is 6 over 2 times A was 1. I replaced the letter B with the number that it was equal to. I replaced the letter A with the number that it was equal to. Gives us negative 6 over 2, or negative 3. So I want to point out what can happen when we plug it back into y. This is why I get a little parenthesis happy. This is why I keep putting parentheses, where you may see, hey, I don't really need parentheses all the time. You can write the 1 in or not. If you plug this in without parentheses, especially if you're using a calculator, negative 3 squared without parentheses is different than negative 3 squared with parentheses. The way your calculator is going to read this is it's going to do 3 squared and leave the negative alone and give you negative 9. The way your calculator will read this is negative 3 times negative 3. What's a negative times a negative? Positive. Well, those are two completely different answers, and it would give you two completely different answers for your vertex. We do not want this one. This is again why I get parenthesis happy, because this specific instance, if I have a negative squared and we plug it in without parentheses, it's going to give you the wrong answer. So we would get 1 times positive 9 plus 6 times negative 3 minus 4. We do multiply next. Again, you don't really have to put the 1 there. We could have ignored it because 1 times 9 is still just 9. 6 times negative 3 is negative 18. 9 minus 18 is negative 9. Minus 4 is negative 13. Again, if you have a graphing calculator and all you do is write that first part and then say this equals negative 13, I do still want you to write that part so you show me your work. But you just say it equals negative 13. You can skip those other steps. Or again, if you have a scientific calculator that will let you write out an entire math sentence and not just plug in one number at a time, then you can plug it in pretty easily.